Hi guys, let's look at the next exercise. Next exercise is exercise 5b and we are looking at numericals of that exercise. But before we start some questions, let's look at what we've already done in exercise 5a. So exercise 5a was about upthrust, where we said upthrust is equal to volume of the solid which is underwater multiplied with density of the liquid multiplied with gravity. That's one thing that we did. The second thing that we did was density is equal to mass upon volume. And the last thing we talked about was apparent weight is equal to weight in air minus upthrust. So that was apparent weight. Now this exercise again involves D is equal to m upon v, which is density is equal to mass upon volume. And then it deals with Archimedes principle, where we talk about calculating the upthrust or determining the relative density also. So the formula that we use in this exercise would be relative density is equal to weight in air upon weight in air minus weight in fluid or liquid multiplied with RD of liquid. So what we have, this is relative density of the solid, that is equal to the weight of it in air divided by weight in air minus weight in liquid multiplied with RD of liquid. So this can be written as RD is equal to W1 upon W1 minus W2 multiplied with RD of liquid. So RD, this is of the solid, W1 is in air and W2 is in liquid. So this is the other formula which we use. I'm sure you've done the theory part of this. So let's look at the numericals and solve some of them. So question number 1, it says the density of copper is 8.83 gram per centimeter cube. Express it in kilogram per meter cube. So common thing for you to remember, like the way I prefer to remember it, density of water is equal to 1 gram per centimeter cube, and this is also equal to 1000 kilogram per meter cube. So you should remember 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. So that's the conversion. Therefore 8.83 gram per centimeter cube will be equal to, basic unitary method, will be equal to 8.83 into 1000 kilogram per meter cube, which is equal to 883 with 10 kilogram per meter cube. So the density in SI unit would be 8830 kilogram per meter cube. Let's look at the next question. This one was very simple. Next question is relative density of mercury is 13.6. State its density in CGS and in SI. Now let's quickly revise what is relative density. Relative density is the density of the given solid upon density of water, and density of water we take it usually at 4 degrees Celsius, which is equal to 1 gram per centimeter cube. So relative density of a substance is nothing but the density of that substance divided by density of water at 4 degrees Celsius. So the density of water at 4 degrees Celsius is 1 gram per centimeter cube, or 1000 kilogram per meter cube. So depending upon the unit, you will take the density of water as either 1000 kg per meter cube or 1 gram per centimeter cube. So when you converting it from relative density into CGS, the value does not change because this is being divided by 1. So if I can solve it once, a relative density is equal to density upon 1 gram per centimeter cube. In this case, relative density is given as 13.6 is equal to density upon 1 gram per centimeter cube, which means density would be equal to 13.6 into 1 gram per centimeter cube, which is 13.6 gram per centimeter cube. So the density is 13.6 gram per centimeter cube. Now, in case you want to convert this into SI unit, I'll show this calculation once again, and after that we will just do the any other question. I won't need to show the calculation. So RD is given equal to 13.6 is equal to density, and the density of water in SI unit is 1000 kilogram per meter cube, which means the density would be equal to 13.6 into 1000 kilogram per meter cube, which is equal to 13610 gone, two more zeros, kilogram per meter cube. So that's 13,600 kilogram per meter cube. So if you converting it in SI unit, you will multiply it with 1000. If you're keeping the answer in CGS unit, whatever is the relative density, that's exactly the density of the substance. Let's look at the next question. The density of iron is 7.8 into 10 to the power 3 kilogram per meter cube. What is the RD? So relative density is equal to 7.8 into 10 to the power 3 kilogram per meter cube divided by density of water, which is 1000 kilogram per meter cube. 1000 and 1000 gets cancelled. Therefore, RD is equal to 7.8. Done. Let's look at the next question. The next question that we do is question number 3. Calculate the mass of a body whose volume is 2 cubic meter and RD is 0.52. So let's just write the information given. The information given says volume is equal to 2 meter cube. And is this question 3? In fact, this is question number 5. I don't know why I've written it as 3, but anyway, this is what question number 5. So volume is 2 meter cube and relative density is equal to 0.52, which means if I want to convert this into density, this would be 0.52 gram per centimeter cube. But since the volume is given in meter cube, let me convert this into meter cube. So this will be 0.52 multiplied with 10 to the power 3 kilogram per meter cube, which is 2 zeros gone, one more. So this is 520 kg per meter cube. So the only formula we know which connects density and mass and volume is density is equal to mass upon volume. So we need to calculate the volume mass, which means mass is equal to density into volume. Density is 520 kg per meter cube. Volume is 2 meter cube. So meter cube and meter cube gets cancelled. Therefore, mass is equal to 520 into 2. That's 1040 kg. So the mass of the substance is 1040 kilogram. Next, question number 6. In fact, I've written this number also wrong. This is question 6, not question 4. So let's read the question. The question says, calculate the mass of air in a room of dimensions something. If the density of air at NTP, I hope you know what NTP is. NTP is normal temperature and pressure. So since the volume changes and the density also changes at different temperature and pressure, this is at a normal temperature and pressure, the density is 1.3 kilogram per meter cube. So let's just write the information available. Density is equal to 1.3 kilogram per meter cube. Volume, so let's calculate the volume. Volume is equal to 4.5 multiplied with 3.5 multiplied with 2.5 meter cube. Like the previous question, we know mass is equal to density into volume. In this case, 1.3 multiplied with 4.5 into 3.5 into 2.5. I have already done this calculation on the side. The answer for this is 51.19 kilogram. It requires a lot of multiplication. Already done it earlier. So the answer is 51.19 kilogram. Good. Seems simple till now. If you have any queries, you're welcome to ask me. Put your message on the YouTube channel and I will come back to you. Let's look at the next question. Next question, question number 7. A piece of stone of mass 113 gram sinks to the bottom in water contained in a measuring cylinder. So basically it is completely immersed in the liquid. Liquid here is water. So mass is equal to 113 gram. Measuring cylinder, water rises from 30 ml to 40 ml, which means volume of stone is equal to 40 ml minus 30 ml, which is equal to 10 ml. Now we know 1 ml is equal to 1 centimeter cube. Therefore, 10 ml is equal to 10 centimeter cube. So that's the conversion. So 10 ml is nothing but 10 centimeter cube. We need to calculate the relative density. Relative density would mean, let's just first calculate the density. So density would be equal to mass upon volume. In this case, mass is 113 gram and volume is 10 centimeter cube. Therefore, density would be equal to 11.3 gram per centimeter cube. And we know if I need to convert density into relative density, and the density is given in the CGS unit, the relative density is exactly the same except for the unit, because relative density is density upon density of water, which means this would be 11.3 upon 1, which is nothing but 11.3. And obviously relative density does not have any unit because it's basically a ratio.